Locating rational numbers on real line. Since rational numbers could be integers, decimals, or fractions, so we should consider each one of these cases one by one. As integers are already marked on the real line, so those are not hard to spot because every real line is already labeled with them. So let's take the case of locating decimals on the real line. And for this we are going to take a typical decimal 1.5. We first of all, as a step one, we will need to find out those two integers between which this number lies. So which number is on the right side, which integer is on the right side of 1.5? That's 2, which is called the ceiling. And which integer is immediately to the left of 1.5? That's 1, which is called floor. So once we identify which is the floor and what is the ceiling, so floor is 1 and ceiling is 2. So that completes our step number 1. So for 1.5, here we spotted the floor and here we spotted the ceiling. And now we take a look on the first decimal place. That's like the digit immediately to the right side of that decimal point. That is 0.5. We have already divided this the space between floor and the ceiling into 10 equal parts, and each division is already labeled, and you can spot where is 0.5. The 0.5 is right here. Therefore our number which we were trying to locate on the real line is right here, 1.5. And let's take example of another number which is also a decimal, but this number does have a 2 decimal place accuracy. Like the number is 0.34. Step 1. For step 1, we want to find out what is the floor and what is the ceiling for this number. So 0.34 lies between which two integers? This immediately to the right of 0.34 is an integer 1, and immediately to the left of this is 0, as it is indicated by this integer that is written as part of the decimal. So the floor is 0 and the ceiling is 1. Let's identify it on the real line. So here is the ceiling and here is the floor. Now we take a look on the next first digit after the decimal point, that's 0.3. If we divide the space between 0 and 1 into 10 equal parts, we can see that this is the place where 0.3 comes. And if we again find the floor and ceiling for the second decimal place number, which is 4, so 0.34 lies between which of the two one-digit decimal numbers. Like this is 0.3 and 0.4. These both numbers will act as ceiling and floor for 0.34. And 0.34, of course, if we divide this space between 3.3 and 0.4 into further 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we divide, then where is 0.33? So 1, 2, 3. This would be the 0.33. And we can continue on that divisions within divisions within divisions. If we were to locate this number, our number 0.34 would be right here. So that is our here. This is, we are back to the page again, and now let's take a look on the another example, which is 1.3. So next example we have is, we are going to locate 1.333. What is the floor and what is the ceiling? Like, which, this floor is already here, 1. That's the floor. So floor is 1 and the ceiling is 2, because 1.333 is between these two integers 1 and 2. So identify, 1 is right here, 2 is right here, and for this first number 0.3 we can easily find because it's already marked, so 0.3 is already here. And for the next, for this 0.3, now we are going to establish the ceiling and floor again for this, and for the second decimal place the ceiling and floor for are 0.3 and then 0.4 right here. And if we divide this space again into 10 equal parts, we can find out that 0.33 will be right here. And similarly, if we further divide the space between these two into 10 equal parts, we can still manage to get another 1.33, and this process continues on. And ultimately, or there is another way that you can convert this into decimal place, this decimal place into a fraction, and then plot that fraction. Now we are going to take a look on how can we plot the fractions. If there is a fraction of 1/7, we similarly are going to establish what our floor will be and what our ceiling would be. So for 1/7, what is the floor? This number lies between 0 and ceiling is equal to 1. So the number, this fraction 1/7 lies between these two numbers. So if we have a real line, let's say that this is 0 on the real line and this is 1 on the real line, then we divide the space between 0 and 1 into how many parts? Into 7 parts, because that's the denominator. So 1, 2, 3, 4, 5, 6 and 7. So 1, 2, 3, 4, 5, 6, 7. If there are 7 equal divisions, mine are not equal, but you got to make them equal. So this is if the denominator is 1, so out of those 7 parts we are going to take only 1. So the 1/7 will be right here. If we further divide, okay, here if we divide further, let's say that we have 2 whole 3/8. So this is the real line, this is 0, this is 1, this is 2, and this is 3. So this 2 whole 3/8 lies between which two integers? This lies certainly between 2 and 3. So the floor for this number is equal to 2, and the ceiling for this number is equal to 3. And how many divisions we make between 2 and 3? We should make 8 divisions. So 1, 2, 3, 4, 5, 6, 7 and 8. And out of those 8 divisions, how many we are going to consider? This many, 3. 1, 2, 3. So this is where we got 2 whole 3/8. That's how we locate a given fraction on the real line. But if there are more than one fractions, let's say that if we had 1 whole 1 whole 1 over 8 and 1 whole 3 over 8 and 1 by 4, 1 whole 1 by 4, 1 whole 3 by 16, let's say, if these were 16. And this usually is the case when we want to read on the inch tape. On the inch tape, sometimes we are required to measure with accuracy to the 1/8 of an inch. Sometime the question is sometime measure to the accuracy of 1/8 of an inch. And sometime this could be, instead of 1/8 of an inch, sometime it says to the 16th of an inch, or even 32 parts of an inch. So let's take a look. I have included one here. So if we want to locate if those numbers on this inch tape, remember this line is dividing the space between 1 and 2 into 2 equal parts. So if we were to find out 1 whole 1 over 2, we should only take a look on this line, because this is the line which is dividing. So 1 whole 1 over 2 will be right here. And if we were to find out the fraction 1 whole 3 by 4, now we are going to consider the lines which are dividing the space between 1 and 2 into 4 equal parts. You can see that those lines are right here, this one, and therefore we have 1, 2, 3, 4. So these lines which are dividing the space between 1 and 2 into 4 equal parts, if we take 3 out of those 4, then 1 whole 3 by 4 would be right here. And if we were to consider 1 whole 5 over 8, now we take a look on those lines which are dividing into 8 equal parts. So these lines here, right, this line, this division, this, and this. So 1, 2, 3, 4, 5, 6, and 7. And these 7 lines are dividing the space between 1 and 2 into 8 equal parts. So if we were to locate 1 whole 5 over 8, 1, 2, 3, 4, 5. So this would be 1 whole 5 over 8. And similarly, if we are to locate where is 1 whole 11 over 16, then we should take a look on the lines which are dividing the space between 1 and 2 into 16 equal parts. Those are right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and well, there is right 11 whole 1 whole 11 over 16 would be right here. And if we were to find out 1 whole 27 over 32, then we should further divide this into 32 equal parts, which I am making right here. And out of these divisions we are going to take 27, and then we should mark that point as 1 whole 27 over 32. But one interesting situation occurs. Let's say that we have a question in which we say, okay, the number we have is 5.32, which is of course decimal. Convert this number into fraction with accuracy to 16th of an inch. For this purpose, what we are going to do, so if we want to convert 5.32 to in inches with accuracy to the 16th of an inch, then this is what we should do. We should take a decimal part 0.32 and then multiply it with 16 and then divide it with 16. Now we are doing this because we want to convert it to an inches with an accuracy level of 16th of an inch. That's why we are multiplying with 16. If we want to convert this number to with an accuracy level of 1/8 of an inch, then we should multiply with 8. If we want to convert it if we want to measure it with accuracy level of 32 of an inch, 32th part of an inch, then we should multiply it with 32. But let's multiply this. 32 when we multiply with 16 will give us 0.32 times 16, that will give us 5.12. So keep the just the integer part, that will give us 5/16. So this will 5.32 is equal to 5/16. That's with an accuracy level of 16th of an inch. If we want to convert it to 30 with an accuracy of 32 of an inch, 32th part of an inch, then we should do so. And that is it for now in this lesson. I'll see you in the next lesson.